Hello everyone. This is the third video in the quantum mechanics numerical session series. Okay, so where we'll see some questions, more questions in the series. And the last question was question number 9, so this will be your question number 10. So question number 10. What is question number 10 says? Consider the state psi is equal to 1 by root over of 19 5 1 minus 1 2 5 1 0 2 5 2 minus 1 root over of 10 phi 2 minus 2, where phi lns are the eigenstates of L square and Lz. Value of L square by Lz is how much? Alright, so see, this is a what? We can write a wave function as psi is equal to summation of CLM CLM phi LM. Okay, summation of CLM phi LM. Right, now phi LM is what? See, for phi LM, for this one, for phi LM we can write phi LM for phi LM. What is L square? There are the L square and Lz, right? So L square is equal to how much? L square is h cut square. L square is h cut square L1 into L plus 1. Correct? H cut square L1 into L plus 1 is a what? Is a L square. Okay, Lz square is how much? Lz square is Lz square is m square h cut square. Right? Lz square is m square h cut square. Alright. So yeah, we will calculate that. Let's do it. This one, see. So L square will be how much? If I write, so L square psi is equal to how much? Summation of C square Lm, summation of C square Lm h cut square L1 into L plus 1. Okay, C square h cut square L into L plus 1 is equal to h cut square h cut square. How can we write it? How can we write it? See, 2. Alright, how will we write it? See the values of this. Is L is 1 here, so L1 to L plus 1 will be 2. L is 1 here, right? L is 1, but this one is the C is 2, right? So C square will be 4. 4 into 2. This one will be 4 into, this is 2 into 2 plus 1, that is 6. So 4 into 6. Okay, now this is root 10 square is 10. 10 into 6. Okay, so we write that. So 2 into 1. So no. So this is 2 only. 2 plus 4 into 2 plus 4 into 2 plus what? C square is what in the next term? C square is 4 and L is 2. So 2 into 3, that is 6. That is 6 plus this is root 10. So square is 10 and 2 whole into 2 plus 1 is 6. Right? This is it. Okay. Whole divided by how much? Whole divided by, see, this is root over a 1 by root 19. So this its square will be how much? Square of root of 19 is 19, isn't it? 19. Alright. So if we add everything, so this becomes h cut square. H cut square. This is 2 plus 8, 10, 10 plus 24, 34, 34 plus 60. That is 94. So 94 h cut square 94 divided by 19 divided by 19. Right? This is nothing else. Right? 94 by 19. Okay. Now LZ square also LZ square. LZ square psi will be what? Summation CLM square summation CLM square what? M square h cut square. This is the eigenvalue of LZ MH cut. So M square h cut square. So that equals to h cut square and this one will become what? See M values. This is LM. So this is your M. M square is minus 1 square is 1. 0 square is 0. Minus 1 square is 1. Minus 2 square is 4. Okay. So just put the values 1 plus 4 into 0. 4 into 0 plus 4 into 1. 4 into 1 plus 10 into 4 plus 10 into 4. Alright. Whole divided by how much? 1 by root 19 was there. So its square will be 19. 19. Right. So this becomes h cut square. This is 1 plus 4, that is 5. 5 plus 10, 40 is 45. So 45 divided by 19. Right. 45 divided by 19, h cut square will be there. H cut square. Okay. So what is the question? Question is expectation value L square divided by expectation value LZ square. So let's write it. L square expectation value divided by LZ square expectation value, that equals to 94 by 19 divided by 94 by 19 h cut square. 94 by 19 h cut square divided by 45 by 19 h cut square. 45 divided by 45 by 19 h cut square. Okay. So this becomes 94 by 45. Is the answer there? Yes. The answer is there in the options. 94 by 45. Option A. Option A will be the answer. Okay. So again, nothing else. You have to just find it the form, that is phi lm. And if you see L, this is the first values are L, second values are M. So L, M, and these are your C's. So the expectation value will be C square, summation of C square Lm and h cut square L will L plus 1 for L square, and for LZ square C square Lm M square h cut square. Right? These are the values. Okay. Next question. See next question. L represents total angular momentum operator. So the value of L cross L is, okay, the value of L cross L. That's the question. L represents the total angular momentum operator. So the value of L cross L vector. Okay. So how will we do it? See, L is how much? First of all, L vector we can write Lx I cap or L operator Lx I cap plus Ly j cap, Lx I cap plus Ly j cap plus Lz k cap plus Lz K cap. Okay, so we will just multiply it with itself. So let me write it. So we can write it in a matrix form, as in determinant form. So this will be your I cap, this will be your J cap, this will be your K cap. I cap, J cap, K cap. Okay, this will be your LX, this will be your LY, this will be your LZ. Okay, this will be your LX, this will be your LY, this will be your LZ. Okay, so if you do it, it will be see I cap is LY LZ minus LZ LY. So LY LZ minus LZ LY minus LZ LY. Then plus J cap plus J cap LZ LX LZ LX minus LX LZ minus LX LZ plus K cap plus K cap LX LY minus LY LX. Okay, minus Ly Lx. Alright. So I cap Ly Lz minus Lz Ly, J cap Lz Lx minus Lx Lz, and K cap Lx Ly minus Ly Lx. This is the matrix, right? So you can put the operator signs over all of them. Okay, operator signs everywhere. X Ly Ly Lx. Okay. So what is Ly Lz? If you simplify everything else, you will get what? You will get I cap, I cap, I h cut Lx, okay, I h cut Lx plus j cap plus j cap I h cut j cap I h cut Ly, okay, plus k cap plus k cap I h cut Lz, okay, k cap I h cut Lz. And if you take IH cut as common, you can see what will you see? If you take IH cut common from there, you will see IH cut LXI cap, LXI cap, sorry, LX, yeah, LXI cap plus LYJ cap plus LYJ cap, okay, plus LZK cap plus LZ plus LZK cap. So this is what? This is your L vector. So this is your IH, this is your IH L vector, right? Yeah, that's it. As simple as that, isn't it? Yeah. So the option will be IH L cut. This one, right? Yeah. Okay. Next question. For the case n is equal to 2, L is equal to 1, M is equal to 0, the value of R at which the radial probability density of the hydrogen atom reaches its maximum is dash A0. Okay, that's dash A0. So, how will you do it? See, given is what? R21 R is equal to this much. So, we know R Let me write it again. R21R is equal to how much? Is equal to 1 by 2 root 6 A naught to the power 5 by 2. Okay. R e to the power minus R by 2 A naught. Okay. So the probability density. Probability density is asked. So probability density is what? Probability probability density. Probability density is how much? Probability density is given at P2. If this is R2 1R, so the probability density would be P2 1R. Okay. P2 1R is equal to what? R square. This is the formula you have to remember. R square R21 R whole square. R square R21 R whole square. So R square is R square, and we will take the square of this one. So that will be 2 root 6 whole square is how much? 4 into 6, that is 24. So 1 by 24 A naught to the power 5. Okay, A naught to the power 5 R square. Okay, R square minus R by A naught, isn't it? Minus R by, so R square becomes R fourth. So I can write it as 1 by 24 A naught to the power 5 R to the power 4 E minus R by A naught. Okay, so this is your probability density. What is the question? For the case of this one, the value of R at which probability density reaches the maximum. So maximum means what will you do? What we usually do? We take the derivative of that one and equate it to 0. So for maximum probability, for what? Maximum, we'll do what? We'll do what? dp1 dp to 1 r, with respect to r we will take because we need that, divided by dr at which point? At it's not given. Okay, at r is equal to r naught, I think. Yeah. Suppose we can leave it. R is equal to 0, right? So that will be d by dr of what is it? D by dr of this one. Let me put that here. 1 by 24 r naught to the power 5 not to the power 5 r fourth r fourth. Sorry, this is not r naught. This is a naught. Wait. A naught to the power 5 r to the power 4 e to the power minus r by a naught is equal to 0. So this one is constant, we'll take it out. 1 by 24 1 by 24 a naught to the power 5. So d by dr of r to the power 4 e to the power minus r by a naught is equal to 0, right? So now just take this one will go to the right side, become 0, and this one will become 4r cube 4r cube e to the power minus r by a naught. Okay, plus so this will be minus because this is the second, we're taking the derivative of the second term, minus 1 by a naught r to the power 4 e to the power minus r by a naught is equal to 0. Okay, Now, just will like take the constant as, sorry, take the common as RQ e to the power minus R by N, and I can take it as common, isn't it? Okay, and this will be 4 minus R fourth by A naught, isn't it? R fourth by A naught is equal to 0. Okay, is equal to 0. Okay, so this is not R four. We took common as R cube. So this is R. So 4 by 4 minus, this becomes 4 minus R by A naught is equal to 0. 4 by R by A naught is equal to 0. So R by A naught is equal to 4. So R is equal to what? 4 A naught. Okay, R is equal to 4 A naught. So the question was what? For maximum is dash A naught. So the answer will be 4, isn't it? Okay, isn't it constant? So is it clear? Like first we took the one that is given R21 R. Okay, then probability density will be simply R square into this one. Okay, and we just took calculated this one. And what is the question? Value of R at which probability density of hydrogen atom reaches its maximum. So we just take the derivative of that, probability is equal to 0. So from there we calculated this and this, and at last we got R is equal to 4A naught. Okay, all right. Is it clear? Is it clear? It's very. It's not hard. It's just that you have to take care of some things. Okay. Yeah. This was your which number question? Again, I missed the numbers. In 10, this one is your 11. This one is your 12. Okay. Next question. Question number 13. Question number 13. A particular mass m being scattered by potential Vr is equal to this one, the differential cross section calculated by Born approximation. Okay, you take your time and try to solve it. You can pause the video if you want. If you want to solve it, differential cross section. All right, so Vr is equal to how much? Potential is given. Vr is equal to G is equal to G del QR, isn't it? Vr is equal to G del QR. All right. Differential cross section. Scattering potential is how much? Scattering potential F theta phi is equal to what? Minus mu 2 pi h cut square. Sorry, 2 pi h cut. Okay, minus mu 2 pi h cut integration of e to the power delta function is here, so I will take this one. I k dot r I k dot r I k dot r vr dr, isn't it? I k dot r vr dr. Okay, and if you have to calculate the differential cross section, that will be d sigma by dr f of theta phi square, f of theta phi whole square, that equals to mu square divided by 4 pi square h cut square, 4 pi square h cut square, and this one is the mod of this one. Okay, square, whatever value you will get here, it's square. Okay, so if I put a vr here directly, so e to the power minus I k dot r, the minus I k dot r g delta qr. Okay, g delta qr. So this is your integration here, and this is your dr. Okay, So this one becomes mu square by 4 pi square h cut square, 4 pi square h cut square. Okay, and see, this is del q r, isn't it? So here r minus 0. So if I will just put in place of r a 0, isn't it? So this whole integration will become 1. You get it? Because why? Because see, when there is a delta function inside the integration del r minus a, suppose, and there is another function that is f of r. Okay. So if the limit is between, like a exists between the limit, then what happens to the integration? It becomes f of a, isn't it? It becomes f of a. So exactly here also, um, r minus 0 is there, so I will just put 0 here. So everything will become 1, only g will be left. So g will go out as g square. Okay, so this will be your answer. Got it? So answer is mu square g. Mu means your mass here taken as m. So m square g square by 4 pi square h cut square. Yeah, option B is the answer. Okay, option B is the answer. All right. Yeah. This is from scattering potential Born approximation. Okay. Yeah, this may come as 2 mark question in GATE or 5 marks in CSR net. Okay. Yeah. Next question. The next question is this one. And hydrogen atom question number will be 14. Okay. Hydrogen atom is in the state psi r theta phi is equal to this much. Um, then the probability of finding 2h cut square upon measuring L square on psi is equal to how much? Alright. Hydrogen atom is in the state this one. Probability of finding 2h cut square. Right? 2h cut square. So if you see 2h cut square, how will we get 2h cut square in the first place? How? If suppose L is how much? L is your L square. Your L square is, eigenvalue of L square is h cut square L1 into L plus 1. Okay, h cut square L1 into L plus 1. Alright, so L is how much? Exactly, L is your 1. So if L is your 1 only, then only the L square becomes what? 2h cut square, isn't it? L square will be what? 1 into 1 plus 1, 1 into 2, 2h cut square. So L square becomes 2h cut square only when L is 1. Okay, when L is 1. So here we have to check what is the which has L as 1, because phi nlm, so the subscripts are nlm, so the second value is your L. So here L is 1, here L is 1, here L is 0, so this won't be counted, okay, for calculating the probability. So how will we calculate probability? We will take the, for the first two terms. Okay, so how will we calculate it? So this will be what? Probability will what? Summation of c square lm, isn't it? Here L only, right? That is L is equal to 2 only we will take. Sorry, L is equal to 1. Okay, so summation of c square, c 1 by root over of 35 square, 1 by root 35 square, 1 by root 35 square plus 3 by root 35 square, 3 by root 35 square. Alright, so this will become 1 by 35 plus 3 square means 9 by 35, isn't it? 9 by 35. Okay, 1 by 35 plus 9 by 35, that will become 10 by 35. Right, the answer will be 10 by 35, and 10 by 35, if we simplify it, we will get 0.29. Right, we get 0.29. Okay, that will be the answer. The answer will be what? 0.29. Okay, this is how you solve this question, because the L is given as 1, right? Suppose you are asked the question probability of finding probability of finding zero upon measuring L square. So you would have taken this term, right, and you would have done probability as root over of what 5 by 7 square, that is 5 by 7 only. Okay, probability of finding what p is equal, probability of finding 0, that will be equal to what, only this term because it has al as 0, so root over of 5 by 7 square. Okay, so that will be your what, that will be your 5 by 7. Alright, that's the answer. Hmm. For 0, this one is for 2 h cut square. Okay, this one is for 2 h cut square. Alright. Hmm. Next question. This is question number 14. Question number 15. Question number 15. So consider a particle in the 1D potential well this one. Small perturbations are added to the well. First are a correction to energy, second energy level. So try it first. Second energy level. Okay. So for the wave function, you have to first the wave function for second energy level will be what? Psi 2. Psi 2 will be what? Root over of 2 by a sine 2 pi x by a. Right? Root over of 2 by a sine 2 pi x by a. This is the wave function for the what? Uh, the wave function for the second energy level. Okay, so E21 will be your energy correction for the second energy level. E21 is equal to psi 2 psi 2 and your this one is potential is given as like W, right? So W psi 2. Okay, so how will we do it? Integration of from what to what? This is x less than equal to like a by 4. So the perturbation is between minus a by 4 to a by 4, isn't it? So minus a by 4 to minus a by 4 to a by 4. So and root over of 2 by a sine 2 pi x by a sine 2 pi x by a whole square into what? Potential is given as what? V naught. So potential is V naught, and that is your dx. All right. So this becomes 2 V naught by a, 2 V naught by a. Okay, and minus a by 4 to a by 4, minus a by 4 to a by 4, um, sine square sine square 2 pi x by a sine square 2 pi x by a dx. Okay, minus a by 4 to 2 v naught by a minus a by 4 to a by 4 sine square 2 pi x by a. All right. So if you calculate it, 2 v naught by a 2 v naught by a sine square we can write it as, but this is minus a by 4 to a by 4. Okay. And sine square 2 pi x by a I can write it as 1 minus cos 4 pi x by a 1 minus cos 4 pi x by a whole divided by 2 dx isn't it? whole divided by 2 dx. So now you just have to integrate it. Okay, and that will be equals to 2 v naught by a, that equals to 2 v naught by a. Okay, um, uh, the 1 by 2 is also there inside, right? So I took it out, and the integration, if you do, the integration will be what, x minus a by 4 pi, because 4 pi by a will be divided, so that will become a by 4 pi, a by 4 pi sine 4 pi x by a, sine 4 pi x by a minus a by 4 to a by 4. Okay, minus a by 4 to a by 4. So if you put the values, see a by 4, if I put here, that will be pi, like pi only. So this whole term will become automatically 0, isn't it? So v naught by a, v naught by a, this will be only x term will only be applied here, a by 4 minus the minus a by 4, that is a by 4. Okay, so this becomes how much, a by 2. So v naught into v naught by a into a by 2, because if you put a by 4 here, see, it becomes how much, sine 4 pi a by 4 a. So only pi is left. Pi sin pi is 0. So both terms sin pi will be 0. V naught by a into a by 2. Alright, into a by 2. So this is your a cancelled out. So the answer will be v naught by a. Okay, the answer will be v naught by a. So this is your so this is v naught by 2. I'm ready. My bad. V naught by 2. Yeah. The answer will be v naught by 2. This is your what? First order correction to the energy of the second, like second energy level. Alright. So a naught by 2, the options are not there. Answer will be a naught by, sorry, v naught by 2. V naught by 2. Okay. Yeah. Next question. Question number, how much it will be? 16. Question number 16. Read the question first. An electron is placed in a magnetic field, uniform magnetic field B, as this one. B is equal to B naught n cap. Okay. Where any points in the direction of vector 2 I cap minus j cap. The Hamiltonian of the system H is equal to minus k sigma b. Okay, where k is less than 0 is a constant. So sigma is equal to sigma x, sigma y, sigma z, Pauli matrices. We have discussed Pauli matrices in the previous session. Energy of the ground state in units of kb naught. Okay, energy of the ground state in units of kb naught will be how much? All right, so let's do it. So unit vector, this one is your vector is given, right? So what is the unit vector along this? Unit vector will be n cap. N cap is equal to 2 I cap minus j cap, 2 I cap minus j cap whole divided by root over of 5, isn't it? 4 square plus 1, 2 square plus 1 square, that is 5. Okay, 2 I cap minus j cap by root 5, and b vector is equal to how much? B vector is equal to b naught n cap. B vector is equal to b naught n cap, and okay. So your Hamiltonian is how, what? Hamiltonian is k minus k sigma by b. So sorry, sigma into sigma dot b vector. So that is minus k by root 5, minus k by root 5. Root 5 I just took out. So you can see one thing here. I can write sigma as sigma x cap, sigma x I cap, sigma x I cap dot, sorry, plus sigma y j cap, sigma y j cap plus sigma z k cap I can write, but k cap is not here. So I just removed it, like I didn't write it. Dot 2 I cap minus j cap. Okay. 2 I cap minus j cap. Alright. So this becomes minus k by root 5 minus k by root 5. This becomes what? Sigma x 2 sigma x minus sigma y 2 sigma x minus sigma y, and this is your b naught. Okay, this is your b naught. B naught was there, so b naught will be there. All right. So now what we know, sigma x is how much? We have discussed in the previous class. Sigma x is 0 1 1 0 0 1 1 0, and sigma y is what? Sigma y is what? 0 minus 0 minus I 0 minus I 0. Okay, 0 minus I 0. So we'll just put them here. So h is equal to what? H is equal to minus k by root 5. H is equal to minus k by root 5. 2 sigma x it was. So 2 into 0 1 1 0 0 1 1 0 minus sigma y, that is 0 minus I 0 0 minus I 0. Okay, 0 minus I 0. All right. Yeah. So now we just simplify it. So minus b naught was there. Okay, I'm missing b naught here. So minus k b naught by root 5 minus k b naught by root 5. This one will be your what? If I simplify it, this is 0 2 plus I, because minus minus plus 2 plus I divided by 2 minus I into 0. Alright, sorry, not into 0, like 0. So see, how will we calculate the energy of the ground state energy? Energy of the ground state. If we can calculate the eigenvalue of this Hamiltonian, okay, eigenvalue of the Hamiltonian. So characteristic equation for this equation will be what? H minus lambda I is equal to 0, isn't it? It's the characteristic equation to calculate eigenvalues. So H minus lambda I is equal to 0. So if I do it, it will be what? H is equal to, so the equation becomes minus lambda 2 plus I 2 plus I whole into, this is minus is there, kb naught by root 5, kb naught by root 5, then 2 minus I 2 minus I kb naught by root 5, kb naught by root 5. This is your minus lambda, and the this one is equal to 0. All right, this one is equal to 0. So if I do the simplification, I will get what? I'll get lambda square minus, try to do yourself from this point, k b naught by root 5 whole square. This is 4 plus 1, that is 5, is equal to 0. Okay, so lambda is equal to what? Lambda square minus k square b naught square is equal to 0. Okay, k square b naught square is equal to 0. So lambda is equal to what? Lambda is equal to plus or minus, lambda is equal to plus or minus k b naught. Lambda is equal to plus or minus k b naught. Okay, so the ground state energy, but the ground state energy is what? E ground state, E ground state is minus k b naught. All right, this is your ground state. Okay, so this is your question. This is the answer for this question. Okay. Here Hamiltonian is given. Uniform magnetic field is given. B is equal to B naught n cap, which is in the direction of vector this one. So you have to find, first of all you have to find the unit vector. Okay, unit vector. Then H is equal to minus K sigma dot B. Put the values of sigma x I cap plus sigma y j cap. So sigma x is 0 1 1 0, sigma y is 0 minus I 0, and B vector is your 2 I cap minus j cap. So this is your 2 sigma x minus sigma y. If we take the dot product, then you just put the value of sigma x sigma y, you do the this one. Then how to get the energy values? If you can get the eigenvalues of this equation of the Hamiltonian, the eigenvalue of the Hamiltonian will be what? Your energy values. So h minus lambda is equal to 0. So I just did this, and this one is your lambda from here, plus or minus kb naught, two values of lambda, but the ground state is what? Minus kb naught. Okay, is it clear? Hmm? Yeah. So this was your what? Which number question? Sorry. So the question number 16. So next is question number 17. Question number 17. Okay. An electron in an eigenstate of hydrogen atom has an energy this much, momentum this, number of nodes in its what? A radial wave function. Number of nodes in its radial wave function. So the energy of the n state is how much? Given En is equal to minus 1.511. If you remember this one, if you can calculate the n value from here, so the formula is what? This is a very simple question. Minus 13.6 divided by n square. Z square, Z, this is a hydrogen atom, so Z is 1, is equal to minus 1.511 EV. Okay, minus 1.511 EV. Alright. So n square is how much? N square is 13.6. N square is 13.6 divided by 1.511. Okay, you will get it as 9 if you calculate it. And n is how much? N square is 9. N is your 3. N is your 3, isn't it? So, see, the question is what? As a measurement of L square is equal to 6 h cut square. Okay. The number of nodes in its radial section. So, what is the number of nodes? Okay. See, for L square, see, L square will be what? We know L square is how much? L all into L plus 1 h cut square. L all into L plus 1 h cut square, and that is equal to what? Here L is what? Sorry, it's given as h 6 h cut square. So for what value of L, this becomes 6. For L value is 2, isn't it? For L value 2, uh, L square becomes 6 h cut square. Alright. So how do we calculate radial nodes? Number of nodes in its radial wave function. That means what? That means number of, the formula for number of radial nodes, the number of radial nodes. Okay, what are the number of radial nodes? What is the formula for it? D is equal to n minus L. We will just subtract the n to L. That would be number of radial nodes. So 3 minus 2. Okay, sorry, minus 1 is also there. N minus L minus 1. So 3 minus 2 minus 1 is equal to 0. This is a number of radial nodes. Okay, so this is our D. N minus L minus 1. Okay, is it clear? An electron in an eigenstate of hydrogen atom has an energy this much, measurement this much. So L square is given as 6 h cut squares. From there you can calculate the L. Energy is given minus 1.511. So from there you can calculate n, that is your 3. Okay, number of nodes in its radial wave function will be d is equal to how much? N minus L minus 1. Okay, this will be your number of nodes. All right, that will be 0. Okay, yeah, that will be the answer. 0 is in a option D. Okay, so these are some of the questions we discussed today. Very interesting questions, and these type of questions only come in exam. So practice more and more this type of questions, and you'll be able to solve them in the exam. Okay. Thank you very much. That will be for today. Thank you.